Hey everyone, this is the Unit 2 review. We're going to start with Unit 1B Standard 1, where we're constructing our free body diagrams. If you have your note card, you're looking at your orange note card or pink note card with all the forces. At this time, you should already know all of the forces and should not need your note card while doing these problems. So if a book is sitting on a desk, which forces are present? We have two forces, Fg, Fn. Fg is always down, Fn is always up. So your free body diagram should look something like this. A football player that is accelerating to the field, which forces are present? That would be Fg, Fn, Fa, Ff. Fg always down, Fn always up. And if it says to the right, then our acceleration is Fa to the right. And I did make a really accelerated arrow to the right, because then the arrow opposing should not be as large. And that would be friction that opposes the motion. For a book falling from a bookshelf, there's only one force. It says no air resistance. So we're going to draw something falling is always just one arrow as it's being affected by gravity. A girl sliding to the left on frictionless ice. As long as she's no longer applying a force, if she's just sliding, she's not applying a force. So she is only supporting her body up, and that's going to be because of the normal force. So it's only two forces, Fg and Fn. Fn up, Fg down. That's it. A swing that is hanging from four ropes. Four ropes creates tension and then gravity. And I'm going to draw a big square so I could draw my four arrows. So these are my FTs and one Fn. Or one Fg, sorry. This one's tricky because why is it rolling to a stop? So something's slowing it down, because if we remember Newton's first law says that an object should continue moving until something else stops it. In the case of here, FF is what's going to stop this ball. So it's FF, F normal because it's rolling on something, and Fg because that one's always present. So if it's moving to the right, opposite to the motion is FF. So my FF force is going to be to the left, followed by Fn and Fg. A marathon runner that is running at a constant velocity. So the difference between this and the accelerated one is that accelerated has an unbalanced force. That's why this arrow is longer. This one should have balanced forces. So it's going to be the same forces, the same forces as the football player, but all the arrows are going to be the same size. So Fn, Fg to the right, Fa, Ff. Number 8, a bag of chips are thrown to the right with horizontal air resistance. What is the diagram of the chips when they are in the air? When they are in the air, nobody is touching them anymore, so there is no applied force. The three forces is going to definitely be the air resistance and Fg. So now we have to figure out horizontal air resistance. They were thrown to the right, and F air is going to be opposite to the motion, so then F air is going to be to the left. Oops, and then Fg down. Let's rewrite that. Fg down, F air to the left. Okay, and then we have a sled pulled to the left with a rope. If a sled is pulling, then we're going to replace our applied force, and we're going to call it FT because it's being pulled with a rope. So this is going to be very similar to this one, except for FA is going to be FT, and it's going to be in the the opposite direction because it's being pulled to the left. So FT in this case is to the left. FT, FF, FG, FN. And all of these arrows should have been about the same size. Michael is pushing a box to the right with 35 newtons of force. If the friction is 10 newtons, what is the net force? So forces are opposite to each other. You subtract. In that case, this gives you 25 newtons to the right. So in the next one, we have 50 newtons and 25. And this one doesn't give you a direction, so I'm just going to keep this as the direction. 25 newtons, right. I'm sorry, I am yawning because we finally got my son to go to sleep. He had to get a shot of antibiotics because he wouldn't take them by mouth. So here we are. All right, we're at 6 minutes in, and I have gone over the front page, and I'm going to create another video. We cannot create videos longer than 10 minutes and upload them to the channel. So I'm going to go ahead and make these or go over these as fast as possible so I can stay within that 10-minute time frame. So calculate the net force for the following problems. 3 newtons up plus 4 newtons down. Don't forget downs and lefts are technically negative numbers, so we're subtracting these as they are pointing in opposite directions. So this is 1 newton down. For this next one side would always cancel. This is the side that cancels. And then you have 8 newtons up and 3 newtons down. So the stronger force is going to be 5 newtons up. In this one, you want to add 10 and 5 gives you 15. And that cancels with the other 15. So you have 10 newtons to the left, 5 newtons to the right. That gives me 5 newtons to the stronger side, which is 10. So that would be to the left. All right, so I'm hoping 5 plus 3 equals 8 newtons. And then these two cancel. So now I have 10 newtons to the right because there's nothing to subtract from this one. For the next one, the 120 is going to again cancel out. So if our 120 cancels out, add 13 and 9. That's 2. Carry a 1, 2, 3, 32 newtons to the left. And then subtract 8. So 32 minus 8. I can't think right now. I'm going to put in the calculator. Believe it or not. 32 minus 8. 24 newtons left. And then here we go. 13 plus 13 is going to give me a total of 26 newtons. So then this side's going to cancel. And I'm definitely going to use a calculator for that one. So 1463 minus 2549. Notice that we're going to get a negative number. The negative number is just telling me the direction at which this arrow is going to be pulling. So down is actually stronger because that's the negative direction. All right. Did I make it within the 10 minutes? Yes, I have a minute to spare. And we're going to create another video.